Hey guys, welcome back. So today, working on this Champion dual fuel generator. This one comes to us actually from another small engine mechanic. He is in high school learning how to fix machines, and this machine belonged to one of his customers. He reached out to me asking for help. He said this machine runs for about 2 seconds and then shuts down. So my immediate thought was either it's low on oil or has a bad oil sensor. So I walked him through bypassing that, and he did manage to get the engine to run longer, but then discovered a much bigger problem. So I already know what's wrong with this machine, but we're gonna start at the beginning and show you how we got there. And then of course, my hope is we can fix the issue. I was gonna say first things first, let's check the oil. But the dipstick isn't really threaded in. I think it's cross-threaded, if anything. But we do have oil, and we are not low. That oil actually looks pretty clean. So let's get that cap secured properly and try to start it. Yeah, I can't actually get the cap installed, so let me look around, see if I can come up with another one that we can use for testing. All right, well, I've wasted about an hour trying to fix this cap. I tried cleaning up the threads, tried trimming off the damaged threads, and went to the storage locker and looked for extra caps. And pretty much every cap I have is either a smaller diameter or a coarse thread. And we need a fine thread of the correct diameter. So there is one option left, which I believe has the right cap, but I'm not happy about it. I am gonna steal the cap from my personal machine, the Honda EU6500. I believe that one is compatible with the Champion. And yeah, that looks like the right part. Perfect. All right, so let's just try this as is. So fuel is on, ignition's on, choke is on. And that's pretty much all it does. It starts, it runs, and then it shuts down. So that is classic symptoms of an oil module shutting the machine down. So to be sure of that, you could just bypass the module or hook up a spark tester and see if spark is lost when the engine shuts down. So that's what we're gonna do. We're gonna throw a spark tester on there, restart it, and see if that is the cause of the shutdown. And this is what we're going to use here. It's just an inline tester with a light. And if you attach it between the plug and the ignition coil, it'll light up pretty solid when the engine's running. And what we want to look for is that when the engine shuts down, does that light go out? So keep an eye on that light. I'm going to restart the engine. And let's see what happens when the engine shuts down. So yeah, definitely a spark issue. We were running fine, and then when the engine shut down, we lost spark, almost like someone flipped a switch off. So definitely a useful tool when troubleshooting small engines. Now we know fuel is not the problem. Obviously, compression and timing are good. Spark is the problem here. And on most machines, there's really only two ways to shut down spark, either with the ignition switch or the low oil module can shut it down. So the easy thing to do would be to bypass the module. Usually they're located right there on the engine block. But Champions are different. They actually put the module up here in the control panel, and there are actually several systems on this machine that can shut it down for safety reasons. One is low oil. We also have a carbon monoxide detector. And this machine also senses if the voltage is too high, too low, or the engine speed is too high or too low. So there's several things here that can shut the engine down, and likely one of those is to blame for the shutdown. So we're going to get these screws out so that we can pull the control panel forward. I did pull up the wiring diagram, and there are 4 modules in here, 2 of which are tied directly to the ignition system, one of them being this carbon monoxide detector, and the other one doesn't say low oil sensor. It's actually called OVF, but it is connected to the low oil sensor as well as the ignition coil, so that is the most likely candidate. The thing that complicates matters is that the other modules, like this gauge, and there's also a module called the control module, which connects over to the propane fuel selector, they kind of connect to each other. So technically, those modules might also be able to trip the engine into shutting down. But the one I went for first was the oil module when I was testing this at the owner's house. And that, by bypassing it, it does allow this to run without shutting down, which is when we found the next problem. So we're in, but the access isn't great. We'd have to start unplugging things and cutting zip ties to get a little bit more access. But as it is, you can see a couple of the modules over here. I think that is the control module. This one is the gauge on the front. And the one over here is the one I'm most interested in because this one ties into the ignition coil and also the yellow wire coming from the oil switch inside the engine. And there's also a third wire, which is a source or ground. So for sure, this can do a low oil shutdown. Now, the thing that's a little bit different is that we also have this plug right here. The white wire just runs over to neutral on one of the legs. And the red wire actually connects over to this sensor or this gauge, which measures the voltage and the frequency. So I think this can trigger a shutdown through that using these 2 wires. So we could unplug this and see if it changes anything, or unplug that, which would completely bypass the oil sensor and the ability of this module to shut down. So I've actually already bypassed that at the owner's house, and it did allow the engine to run. So we're going to do the same here, which is then going to highlight the next issue. All right, so that is unplugged. So this module cannot shut the engine down. So let's restart it and see what the bigger problem is. So let's try this again. This time I did plug in a light in the kilowatts since the engine should run more than a couple seconds. And that brings us to the real problem on this machine. It's not a bad oil switch or a bad oil module. It was actually doing its job because it's also tied in to the gauge and monitoring the voltage and the frequency. And it saw that the voltage was out of spec. In this case, we're not producing any power. This gauge remained dark, the light didn't turn on, and the kilowatt also didn't power up. So the issue with this machine is that we likely have a bad stator or a bad rotor. So we're going to dig in here and run a few tests to see where the failure is. If we're lucky, it's a bad set of brushes or a bad AVR. But more often than not, it's actually a bad rotor. At least it seems that way. Most machines that come to me not making power in the last few years, it's usually a broken wire on the rotor or a bad solder joint. The main reason being that, that rotor spins at 3,600 RPM. And if it's not built well enough to withstand that force, eventually a wire breaks. So I'm actually going to leave the brushes on. We're going to test through the brushes to the rotor. If it tests good, then we know the brushes are good as well as the rotor. And if it tests bad, then we're going to have to remove the brushes and find out what's bad. Is it the brushes or the rotor? And for this, we just need a multimeter that can measure resistance. On the rotor, between 40 and 70 ohms is what you normally get. Through the brushes, it's going to be a little bit higher, but not that much. And in this case, we are open circuit. So yeah, either we have bad leads, which looks like we don't, 0.1 ohms, or a bad rotor, or maybe bad brushes. So let's pull the brushes off. And we can just do the same test here. We have 2 terminals, 2 brushes, so we can put 1 lead on 1 terminal. See if we have a connection to the brush, which we do. It's about 3 ohms. And if we check the other brush, we should also get a fairly low connection, which we do, around 2 ohms. So the brushes are good. So the bad news is likely it's the rotor that failed, but we can test directly on the slip rings to make sure. And yeah, it's fluctuating quite a bit, but that is about 4 million ohms, where it should be about 40 or 50 ohms. So yeah, rotor, it's bad. So yeah, without a doubt, that rotor is damaged, and this generator is never going to make power like this. So we do need to pull the stator and the rotor and just size up the damage and figure out what we want to do. So before we can do that, we actually have to remove the exhaust because it's bolted on to the stator. And I'm also going to remove the tank just to get better access to what we need underneath. So we're just going to pull this panel off so you get access to the fuel valve and the fuel line. And we're going to temporarily clamp this fuel line where it comes out of the tank and disconnect it from the valve, which is attached to the frame. So that's going to stay behind when we take the tank off. And the clamp is actually rusted away, so that's not good. Actually, this machine does have a bunch of rust on it. I mean, you can tell it was stored outdoors, and I think that is definitely a factor in how these rotors fail. Here we go. And if this plug fits, we can use it to cap the line, which it does. And then I can remove the clamps. Yeah, that clamp is rusted as well, so we need to carefully remove it. Being careful not to break that plastic barb. Then just 4 bolts hold us on. So these were kind of crusty. Yeah, I did spray them down with penetrating oil, so hopefully they come out. There he goes. Yeah, I'm not sure we're actually going to be able to get this tank out. The control panel kind of wraps around it, but I think we can likely slide it a bit. There we go. And set this aside. And we'll just soak all this stuff down for what it's worth. And by removing that cover, we now have access to the bolts here that hold the exhaust onto the head. And the bolt here on the right doesn't look great, so hopefully that breaks free. Let's start with the easy one. All right, that one's turning. And let's try the other. Yeah, that one's turning too. Not very well, but it is turning. And this one we can spin out by hand. So I'm going to leave it in just a bit. We got 2 more bolts here on the stator side, and the exhaust should be free. And let's see if we can get this off. We don't have a whole lot of clearance here. We need to pull it far enough away from these studs to free it. And just sizing it up, it doesn't look like we're going to be able to do it. Ooh, just made it. Now we can get all this stuff disconnected. So I'm going to start with the auxiliary winding, which are these 2 green wires. And let's actually cut the zip tie away. And we'll pull that out. Now it's kind of odd. We have the neutral and the ground kind of holding these wires in place. Usually use a zip tie for that, but in this case they didn't. And then we have the 2 blue wires. Those are common together, so those are the neutral coming from the stator. We have a red and a black. Those are the live wires. And this one, it is bonded. So the neutral comes over from this neutral post and goes right to ground, where the ground wire is also connected. And we're just disconnecting the wires here that run up to the control panel. The stator wires, technically, we can just leave them right where they are on this terminal block. And I guess the only catch is we do need to remove the block so we can get the puller in there. So let's do that now. So we're going to get off these mounts next, but I just want to highlight some nice features here on that Champion machine. Not a sponsor, but they definitely go above and beyond what I see on most machines. You know, take the brushes, for example. We have a metal bushing and also a backing plate, which most machines don't have. Even down here on the engine mount, we have a heat shield to protect it from the heat that the exhaust produces. And even the shutdown we were experiencing. You know, most machines only have a low oil sensor. This one also checks voltage and frequency, which most machines don't. You know, I've seen machines outputting about 50% more voltage than they should, and they just keep running, you know, sending power to your house until something burns up. So definitely some nice features. Wow, that is on there pretty tight. But it's finally moving. I think we're going to get this handle out of the way as well. Huh, not a good sign. Stator bolts are in there pretty good, and we have to be careful because if we break it here, then we now have engine problems. So let's soak that a bit with some penetrator. And we'll try it manually just so we can get a feel for things. Okay. It is turning, but it's tightening up. So we're going to go back the other way and kind of work it back and forth until things loosen up a bit, which it doesn't feel great, but it is coming out. All right, there's two. Ooh, that one doesn't feel good at all. Let's try the bottom one. It's moving. And now we're down to 1. So these are definitely not coming out well. Probably some of the worst I've tried removing. All right, it's turning. So we're going to try to pull this off with the 2-jaw puller, being sure not to pull on the side where the brushes go in, because that is the weakest side. And really, this whole housing is very weak pulling in this direction. So if you start to build any pressure, you need to stop. But in this case, it's coming right off. Very nice. And right away, I'm seeing a bunch of corrosion right there on that solder joint. So that's the prime suspect. Although the wire doesn't move around, so maybe that is not the issue. Let's check the other side. And hard to tell, but that one looks like it's attached as well. So I'm going to use the multimeter in continuity mode and just test from one slip ring to the terminal. I want to make sure that's at least good, which it is. And we'll do the same on the other. And that's good as well. So we know the slip rings are good, the terminals are good. So the failure has to be most likely the connection of the wire to the slip ring, but that one does feel pretty solid. And so does that one. Yeah, I'm not getting anything at all from this bare spot from the terminal, but if I go to the slip ring, we get a good connection over there. So we get nothing at all on this side. And the other side didn't seem great, but let's try cleaning that up again. And redoing the test. So we have a good connection from the tab to the slip ring. And a good connection from that bare spot to the tab. So I don't think we have an issue over there. Seems like this could be the issue right here. So good connection from the tab to the slip ring. And I can't get anything on this wire. So the failure has to be here. Although looking at it, you know, it's not obvious. Interesting. So yeah, I would say the failure is right here between this wire and the connection to the terminal. You know, although the wire is good, the terminal is good, there's something wrong with that connection. So I am tempted to try to reflow this. The problem is this is actually varnished aluminum wire. You know, I don't think this is copper clad, and soldering this with normal solder isn't really going to correct the issue. Although I guess it can't hurt. So yeah, let's try it real quick. Yeah, it's not even touching that solder. So this is a high thermal mass iron. And that solder that's on there, it's acting more like glue than solder. So from the slip ring to the solder blob, we have a good connection, but absolutely nothing to that wire. So yeah, no big surprise. That did not fix the issue. In fact, I don't even think it melted the old stuff that was on there. So I'm not sure what it's made out of, but my iron didn't touch it. So although we still have a connection from the slip ring to the blob of solder, we don't to the wire right next to it. So, you know, it was worth a try, but either way, the owner wants this one replaced. So let's pull it off. I think that did it. And now that it's off the machine, we might have an easy replacement here. So, you know, I do have extra rotors. Most of them are off in the storage locker, but I do have one here in the shop. And on first look, it appears to be a pretty good match. This came from a PowerMate, but also a Honda clone. So it should have the same tapered shaft fitting on the fan side. And the other critical dimension is the length. And from what I can tell, these appear the same. So let's check that real quick. And if that's the case, we should be able to exchange the bad rotor and put this one in its place. And this machine should work again. And yeah, they're identical. So I think we can use this one. I guess the only other concern is the placement of the slip rings. These do look like they're pushed down a little bit more on the shaft, and that might cause an alignment issue. But I say we fit this one and find out for sure. So we are close. The brushes are on the slip rings, at least partially, but they're a little bit too far in. So the good news is, being that they're too far in, we can actually use like a washer or two as a spacer and actually move the brushes out just a bit, and that should land the brushes fully on the slip rings. So I'm going to add 2 washers here on the locating pin side. And that's kind of the limiting factor. You can't add so many washers that that pin becomes ineffective. You know, as it is right now, we could probably get away with adding 3. And I've also added 2 washers on the side with the bolt. So by doing that, that's going to move the brushes out closer to the ball bearing. And it's going to center things up a little bit better on the slip rings. All right, let's see what that looks like. Yeah, it's a lot better. I would say almost passable. But I think one more washer is needed to get the brushes 100% on the slip rings. So we're going to stack 3 here on the right. And that might be too much. Oh no, we still got enough room there. Just barely. So yeah, this is going to work. With the 3 washers on each side, we now have the brushes aligned properly on the slip rings. So before we reconnect all the wires, I actually want to pull the stator back off. I'm going to clean up the slip rings. I do want to test the rotor, make sure it tests well before finalizing the install. So we're just going to clean this up with a little bit of Scotch-Brite. And these slip rings technically aren't that bad. You know, the carbon itself isn't going to cause much of an issue usually. It's just if there's dirt or corrosion, then you want to make sure that's removed. So we're just going to go around it, get all of that off, and then we actually need to test the rotor, torque that bolt down properly, maybe blow some of this dust off, and we should be good to get this together. And let's make sure this is good. A healthy rotor should be between 40 and 70 ohms. And this one's perfect at 45.7. And since we're here, I do want to secure one point of failure, which is this solder connection right here. It likes to vibrate and fail. The Champion actually didn't have that. It was a continuous wire, and the only failure points are really the connections to the slip rings. But this, I would say, is just as likely to fail. So I'm going to put some JB Weld on top of it and secure the wire to the plastic. And we'll put a little blob on the other side just to help balance it out. But first, I want to scuff up the plastic a little bit and also clean it with a little bit of rubbing alcohol. This will just help the JB Weld adhere a little bit better. I'm just pushing that down right to the plastic. And we don't need a lot here. We just need to put enough so that the wire doesn't vibrate. That should minimize the chance of it breaking. I think that'll be good enough. So I'm going to rotate it and do a similar blob on this side. So that is going to require about 24 hours to cure. So, while we're waiting for that to cure up, let's get everything back together. And then at this time tomorrow, we'll try it out. But before we get the stator back on, let's clean this up a little bit while we have access. So we get the stator bolts back in loosely, and then I want to set this down and make sure the stator is oriented correctly. The threads, they have been cleaned and lightly oiled, so these bolts should go back in fairly easily. Wow. The terminal for one of the live wires just fell off. Huh. Haven't seen that one before. So the question is, are the others damaged? And no, they seem good. So for whatever reason, this one completely fell apart. So yeah, that poses a bit of a problem because we only have so much wire to work with here. So we need to get this off. And just keeping in mind, we don't want to remove much wire. Otherwise, we're going to have a problem. And might be able to get a piece of shrink tubing on there. Like that. And that's on there pretty good. So I think that'll do. Just get the shrink tubing pulled up and shrink it down. And the big question is, does it reach? Yeah. Thankfully, it does. So we'll get these wires back on their terminals and connect it up to the control panel. So we'll snug up leg 1 and leg 2, but we do still need to actually run that jumper from neutral to ground. So we'll get the jumper on, and we'll just put the nut there to hold it loosely. And we'll secure the neutral to the ground, then tighten everything down. And we'll get these resecured. I am going with a slightly longer bolt, just due to the increased space from the washers. The old bolt was a little short now. Gonna pull this tin off real quick before we get the exhaust on. I see a little bit of something here which could impact cooling. Yeah, not a whole lot, but there is a bit of buildup. Looks like we need a new breather. This one almost looks like it was cut. I'm guessing it's just dry rot, so let's pull this old one out and we'll check the air filter while we're at it and replace that too if needed. And we're going to replace this with a Generac breather tube. There's the part number if you need it. This fits pretty much all, or at least most, engines in the 390cc range that you'll come across on a generator. And something I neglected to check earlier, as soon as you get the stator on and the bolts torqued down, turn the engine over. Make sure that there's no binding or rubbing between the rotor and the stator. If there is, then you have to pull it off, try it again until the engine rotates without issue. And in this case, it rotates nice and smooth. And we're also going to replace the plug. It is rusted a bit, at least on the outside, and it appears to be a clone plug. So we're going to put a brand name NGK BPR 6ES in, gapped to 30 thousandths. And last but not least, let's have a look at this filter, make sure it's good. And yeah, the filter itself is nice and clean. We do have some dirt and mud in here, so let's clean that out. Maybe blow the filter off and re-oil it. But the good news is it is nice and clean where it needs to be. And I just noticed this boot is all torn up. I was thinking about replacing it with a brand new boot, which isn't a big deal to put on. You just disconnect all the wires we already connected. But the one thing I'm noticing is that this auxiliary winding, this connector is way too wide to actually slide off the boot and get the new one on. So they must have put this on after the fact. And theoretically, we might be able to depin this. That's really the only chance we have, is to remove the pins, slide everything out, and get the new boot on. So I'm going to spend a second and see if I can get the pins out of the connector. Okay, we've got one out, so I'm going to mark that so we put it back in the right place. Although I believe this is AC, so it's probably not going to matter, but just to be safe. And there's the other. And we still have part of the boot here. It's actually taped to the main wire harness, but I think we can just cut that off and leave the rest of the tape. And I'm also going to reconnect this carbon monoxide module as well as the low oil module before going for the first start. All right, it's been just over 24 hours. We've got this machine plumbed into the test tank. The old rotor is out. The good one is in. So we're going to do the same test that we did last time with the light and the kilowatt. And hopefully this time they both power up and the gauge on the front comes on. So let's pull the engine over and see what we get. All right, let's try this out. Ignition's on, fuel's on, choke is on. Interesting. So the carbon monoxide lights started flashing and the power shut off. So are the two related? I'm not sure. You know, the gauge stayed on, so I'm not sure what to think about that other than, you know, trying to restart it and see if that resets. All right, so it seems like maybe the GFCI is bad or maybe this light is bad. So I'm going to reset the GFCI, unplug the light, and we'll keep an eye on it. There is actually a green light that will illuminate, you know, if the GFCI is not tripped. So again, ignition on, choke partially on. All right, all the way on, and we get nothing. How about choke off? And it looks like we have a bad GFCI because it tripped again. This time the light was not plugged in. So we do need to order up a new one of those. You know, otherwise things are working pretty well. Although one thing I kind of am curious about is the hour meter to see, you know, what the hour count is on this machine. So we'll start it one last time. Give it some choke. Choke off. Choke on. Yeah, it's hard to believe it. This machine is about, I would say, 13 years old. And according to the counter on the front, it only has 4 hours of runtime. And during that time, bad rotor, bad GFCI. So luckily, the machine is making power. We don't have any problems there. Although it did give me a little bit of a scare when that light turned off. But yeah, new GFCI will get us back up and running to 100%. So I am going to change the oil while it's hot, and then we'll finish getting this machine together and then wait for that part to arrive. All right, so let's get this oil changed out. There's a pretty good chance this is the first oil change this machine has had. Now the wheel, it's kind of in the way. I think we can sneak in here. I think I need the breaker bar for this one. There we go. Yeah, it might be a little bit of water in there. Kind of has that milk chocolate color. And there's an up-close look at the oil. Not in great shape. You know, it is definitely contaminated with a bit of water. But the good news is I don't see any engine glitter in there. So, you know, despite the contamination, I would say the engine is in good health. I think it's also safe to get this end cover back on. So I kind of actually like the routing of these wires. Usually you have to zip tie them because they're all bunched up in the corner here. It can fall in. But this wire cannot fall in, and neither can that one in its current configuration. So no need for a zip tie on this one. And I think before we get this tank back on, we're going to clean it up, but I'm also going to drain out the fuel. I'm not sure, you know, how fresh it is, so we'll get it out, get some new stuff in, and that way we know it's good. Yeah, the fuel actually looks pretty good. I don't think it's been in there too long. So with the exception of the bad GFCI, I think this machine is pretty much good to go. But that brings us to our next problem. Although Champion has a parts diagram and they have a part number for this GFCI, when I actually search for that part, for anybody selling that part, I come up empty. So potentially, if I called Champion directly, I could buy the exact part for this machine. But yeah, I'm not going to hold my breath on that. Plus, paying the OEM price and waiting for shipping, that is time and money. And I have a bunch of control panels in the storage locker that I'm willing to bet one of them has the part we need. So I'm going to take a quick trip out there, and hopefully we come back with something we can use in this one's place. There we go. Got a winner. And this right here, I think, is the part we need. It looks exactly the same. Even has the little green indicator light right there. And this is from a newer Generac model, although it did have 710 hours on it before it blew. But I'd say it's less than 10 years old because these hour meters almost never work past the 10-year mark. So let's harvest this and hope that it's good. So we just have 6 screws here in the back. Once removed, I was going to say, I believe this comes out on the front. I'm not so sure. This design looks a little different. So let's remove the bolts and find out. Yeah, so we are free, kind of. This chunk of plastic kind of in the way. So we might need to remove some more fasteners, although not on the back side. It looks like these are all on the front underneath this label. Yeah, it's kind of an odd design that these fasteners are hidden on the front side, whereas the control panel is on the back. And not that I plan on using this anytime soon, but I kind of hate to ruin it. But we got to do what we got to do. Yeah, it looks like this is a tamper-resistant Torx. So if you needed to get in here for some reason to service something in the control panel, you're going to need 3 different tools to do it. And you're also going to mess up the front of the control panel. And actually, yeah, that does have to come off, but we also have 2 other bolts here, which are a different size. So you need actually 4 tools. Okay, and we're in. Looks like just a nut on the top, a nut on the bottom should free this outlet. And then we can kind of pull it out, disconnect the wires, and move it on over. There we go. All right, so we got the ground wires. And same issue with this one. It is like a fork connector. Although I see the problem. It is kind of hugging the screw a bit, which isn't a bad idea. Anyway, one terminal left here, which is the neutral. Okay, we got our prize. Let's move it on over. I was just getting this back together, and it occurred to me, this cutout here makes it look like the sensor for the carbon monoxide is right there. But there is nothing on the front. You know, this is all for show. The sensor is actually in the back. I ended up unplugging this module here on the left, gave me some more space, cut a few zip ties, and I'm thinking if we remove or unplug some of these others, that might give us a little bit more room to work with. Although not much. But it might be enough. Not quite sure how this is going to get back on, but it is coming off. Okay, we got the old one out. Let's get the new one in. And we'll get the new one in. Though I use the term new pretty loosely because it's not new. It's newer. And hopefully works. All right, so I'm just going to get all these connectors plugged back in, and we do need to start the machine and just make sure that the GFCI we installed works properly. And we also need to reset, actually the good one, because I accidentally hit the test button, and that does not reset when there's no power to it. So now that we're theoretically done, we need to test it and just make sure. So I've got two lights plugged in. The one on the left is plugged into the good outlet, and the light on the right is plugged into the outlet we just replaced. Now, I'm pretty sure I tripped this by accident, so we're going to have to reset it, and potentially we might have to do the same to the one we just installed. So to run this machine, we ran it the first couple times on gasoline, but the tank is now empty. So instead, we're going to use propane, and we don't have the OEM regulator. So this is the one that I use on some of the larger standbys, which seems to be compatible. So we're going to give that a go. Now, being that this is a native dual fuel machine, it actually has a nice feature that you wouldn't get if you converted a machine yourself. And that is basically a safety system. Because if you convert the machine yourself, theoretically, you could leave the fuel valve on and hook up propane and turn it on and start the engine. And then it's going to be running on propane and gasoline, and the engine's going to run way too rich. With this setup, that is pretty much impossible because you have to slide this to the right to indicate that you want propane. And this is going to rewire some things so that you can only run on one source of fuel. You can't run on both at the same time. So this mechanically requires you to turn the fuel valve off and slide this over, clicking that switch. So by doing that, you're actually preventing a couple problems. First, this fuel valve, if it was on, you were going to run rich when running on propane because it'll be feeding gasoline as well. But even if the tank is empty, that is an air leak. If that fuel valve is open, then air comes in past the needle, mixes with the propane, and things run leaner than it should. So this ensures that things are going to run properly. And it also handles another problem, which is the gasoline that's still in the carburetor. So as it is right now, when I try to start this, it's going to take quite a few pulls because there is air in the system. But we do have some gasoline still left in the carburetor. So when we start it now, it's going to start on gasoline, and as soon as the generator starts making power, some of that power is going to be rerouted to the fuel solenoid on the carburetor for the gasoline. It's going to close that, blocking the main jet, and at that point, you're going to be running on 100% propane and get an easy start out of it. So yeah, pretty nice feature. So let's get it started, make sure everything works. All right, so let's give this a try. Turn the ignition on. Also plugged in the kilowatt. Although we checked the voltage before, we never checked the speed. So, it sounded correct, but we want to make sure that it is. This is also a propane valve here. So again, it ensures you can't have them both on at the same time. So we'll turn the choke on. Let's try to start it. All right, choke's now off. Well, I think the last issue here is sorted out. I was actually kind of surprised that both the lights turned on. I was fairly certain that I accidentally tripped this breaker or this GFCI while working on the one here on the right. But that was not the case because they did come on right away, and more importantly, they stayed on. So that issue has been sorted. Also, the engine ran quite well on propane, starting in only 2 pulls, and the engine speed was pretty much dead on at 61.3 Hertz. So let's get this outside and put it to the test. All right, so let's try this thing out. We are connected to propane, and when running on propane, this machine's rated at 5,600 watts. If you want a little more power, you can run on gasoline, in which case you can pull about 6,250. But in this case, 5,600 is likely the most we're gonna get. So the plan is to get the engine started. While it's warming up, we'll double check the output using the kilowatt to measure the frequency and the voltage. We use the amp probe to measure the total harmonic distortion. Ideally, you want 5% or less, but on something like this, likely we're going to see 20%, if not higher, under full load. And we'll also use the oscilloscope to see what the waveform looks like. If everything checks out, we'll put on a half load, give it a few minutes, and then we'll go for the max of 5,600 watts. Pretty impressive. Most propane generators I struggle to start with the pull start, but this time it started first pull. The voltage looks good at 122 volts. We're also at about 60.7 Hertz, and likely that'll come up a little bit as the engine warms up. Without a load, we're at about 4% THD, and the sine wave, definitely jagged, but pretty typical for a machine like this. So let's put on a load. Start with 2,000 watts. No issues. We'll add another 500. And we'll leave it there for now. So we're holding at about 60 Hertz. THD went up some, but still not terrible at 14.5. But the sine wave does not look great. Anyway, we'll give this a few minutes, and then we'll go for the max of 5,600 watts. It's been a few minutes, no issues at all, pulling 2,500 watts, which there shouldn't be. This machine's rated for quite a bit more. You know, as far as the waveform goes, I did recalibrate it a bit, so now we can fit the entire wave properly on the screen. So not quite as bad as I originally thought. So let's bring the load up to 3,500 watts, 4,000 watts, no issues. Let's swap the smaller loads back to 4,000. How about 5,000? Yeah, it's struggling. So I'm not sure we're going to be able to get any more out of this. But when you take into account we have 200 watts on the cooling fans, 100 watts on the light, we're at 5,300 watts. Technically it can do a little more, but looking at the engine speed, I'm not so sure, but we'll try it. 5,500 watts. It's doing it. So I guess we'll leave it there. At that kind of a load, full load, 16.8% THD, and the sine wave looks mostly unchanged. So let's give this a few minutes, make sure there's no surprises. Alright, it's been a few minutes at 5,500 watts, plus these extra loads. We're actually at about 5,800 watts, so it's doing it, but we're definitely out of horsepower when running on propane. The engine speed is slowed to 57.5, which technically is still acceptable, but it's kind of right on the edge. You know, if we throw any more at it, the engine's not going to be able to do it, at least while running on propane. So let's take the load off, and we'll give the engine and the load bank some time to cool down, and then we'll shut it down. Well, that's interesting. The ignition switch no longer working. So we'll shut it down by killing the fuel. But that switch worked when we were testing it, so I'm not sure what changed. So maybe one of the wires got knocked loose, so we need to pull those screws back out of the control panel and take a quick look at what's going on. Actually, you know what? It occurs to me, when we tested this on propane inside, we didn't use the switch to shut it down. We used the propane fuel valve. So now I'm wondering if this is a feature and not a flaw. You know, these connections, although I wouldn't say they're super tight, I also can't pull them off, so they're somewhat on there. So I think maybe I should have a look at the manual before going much further here. All right, so I did check the manual, and it wasn't very helpful. It said, regardless of what fuel you're running on, shut the fuel valve off first, then the ignition switch. So yeah, I don't know if this is a feature or a flaw. I guess the easiest way to tell would be to put gasoline back in the tank, which I kind of hate to do. You know, on propane generators, most people buy them to run on propane and avoid the issues with, you know, having gasoline in the tank. So I'm just going to get these reconnected. There might be some other tests we can do. But the fact that we have 4 wires coming out of this switch tells me that there is something a little different going on here, because usually you would only need 2 wires to kill spark. So there is a signal going somewhere else. And with all these modules in here, you know, it wouldn't surprise me if, when running on propane, maybe they want you to shut the fuel off to shut the machine down, but it's not very intuitive if that's the case. All right, those are connected better. And I think what I'm going to do is just use the spark tester. I'm going to have the switch in the off position, but still in propane mode. And, you know, based on what we saw, unless we just fixed it, we should still have spark. And then I'm going to switch over to the gasoline mode, pull the engine over again, and see if spark goes away with the switch off. So we're going to try testing for spark with this tester. It's probably the easiest one to see out in the daylight. Right now the propane tank is off, so this machine should not start, and the fuel valve on the machine is off. Still in propane mode, ignition's still off, and I think we're going to see spark. I mean, that's what we saw when we tried to shut it down. So 2 good pulls, and the tester says, yeah, we have spark. So let's reset this. And we'll go back to the other side of the machine. Ignition's still off, but we're going to switch to gasoline mode. And because of these switches, things are getting rewired. So now we should not have spark, if my theory is correct. Yeah, and the tester agrees, no spark. So let's reset it. And now in gasoline mode again, we'll turn the switch to on. Give it 2 more pulls. And we have spark. So the good news is there's nothing wrong with this machine. It was designed to behave like this. All right, guys, and that is pretty much it. So this machine, it had a surprising amount of problems. Now, granted, it is 13 years old, and I think it has spent some time outdoors, but it only had 4 hours of runtime on the clock. And it had a bad rotor, a stripped out oil fill, and it also had a bad GFCI. So for most generators, that would be a death sentence. There is no shop that could fix it for less than the worth of the machine when it was new. Luckily, I had most of the parts on hand. The only thing I didn't have was that oil fill cap, so I did have to order a replacement for the one that I stole off the other machine, but that was only 25 bucks. So that, plus a few hours labor, and now this machine is back up and making power like it should. As far as the load test goes, no issues there. But under its rated load, it was struggling. So it for sure cannot really exceed its rated load on propane. But it did do it. And the THD also not terrible. Not great either. I think we maxed out at about 16, maybe 17%. But overall, it is functioning like it should. And even that ignition switch almost sent me down the rabbit hole. But that is also a design feature, and there's actually nothing wrong with it. Although Champion doesn't spell it out in their manual, they do say shut the fuel off first, then the switch. So yeah, as long as you do that, you're not going to have a problem. So I hope this video helps someone. Thanks for watching.